Alright everyone, welcome to the review for exam number 2. I'm going to be going over some problems that you will be certain to see on the second exam. The second exam will cover the topics from the chain rule all the way up to relative extrema, including the max and min values that we did last time. So without further ado, let's start with a simple problem. And it's simple in the sense of it is probably the simplest problem on the exam, which is simply find the derivative of the following: y equals cosine of, let's say, 3x squared plus 5. Here we have to realize a couple of things. Number one, we have something of the form y equals cosine of u. However, inside of cosine, on this inside piece, we have another function. It's not simply cosine of x as we had prior. So this is not what we're looking for. We're looking for something of the form cosine of u, where u is another function. Whenever we have a case like this, where we have a composition of two functions, two or more functions, we use the chain rule. Now, what the chain rule says is, if I'm taking the derivative of cosine of u, then that will be the derivative of cosine, which is negative sine of u, but I have to multiply by the derivative of this inside piece, which we'll call u prime. So that's what we expect the derivative to be. So now going back to our problem here, before I even begin taking the derivative of cosine and whatnot, I like to first identify what is the inside function. The inside function is 3x squared plus 5. The reason why I do that is because I know that I'm going to have to use a chain rule, because there are two different functions here. As soon as you see two different functions, you know you're going to have to use a chain rule. Once you know that you have to use a chain rule, you should be identifying what is the inside or the inner function of the composition. So here it happens to be 3x squared plus 5. Well, what is the derivative of 3x squared plus 5? By the power rule, that would be simply 6x, because the derivative of 3x squared is 6x to the first power, and the derivative of 5 is just 0. And now if I applied the substitution, I have y prime is equal to negative sine of u times u prime. That I got from here. But now the problem was given to us in terms of x's. So let's actually substitute back what u is equal to. U is equal to 3x squared plus 5. So this is negative sine of 3x squared plus 5 times u prime, but we calculated u prime to be 6x, so times 6x. If you want to clean this up a little bit, this will be equal to negative 6x sine of 3x squared plus 5. So again, this is a simple problem using the chain rule. Let me do another one just for practice. Let's say now the function is given to you as the cubic root of let's say 3x minus 5x squared plus e to the x. All right, so again, I have a radical. When you see a radical and you're taking the derivative, you will always be using the chain rule. So if you, before you even begin to take the derivative, what I suggest that you do is actually rewrite it. It will make your life easier if you rewrite this as 3x minus 5x squared plus e to the x to the power 1/3, because then you can clearly see that you will have an inside piece, which will be this, and you're raising that to the power 1/3, which means that we will use the general power rule. Now again, let u be the inside piece as 3x minus 5x squared plus e to the x. Then the derivative of u, which I'll call here du or u prime. So remember, u prime is the same thing as du, which is the derivative of this, which is just 3. The derivative of 3x is just 3, minus, by the general power rule, 5 times 2 is 10, so minus 10x. And the derivative of e to the x is just e to the x. now we can actually move on and take this derivative. This derivative is going to be equal to, well, let me rewrite it first. That's 3x minus 5x plus e to the x to the power 1/3. So by the general power rule, if I rewrite this, what I have is y is equal to u to the power 1/3. This will make the problem much nicer. Remember, u we said was this, but now here we could see that the power rule applies. So you bring the 1/3 down, so that's 1/3 times u, then we minus 1 here. But if you minus 1 here is the same thing as taking away 3/3, which is equal to negative 2/3. So we have u to the negative 2/3 times, by the chain rule, the derivative of u, which is u prime. Okay. So now, once again, we were given this problem in terms of x's and y's, so let's put it back in terms of x's and y's. This is the same thing as, and in fact, before I do that, let's actually bring this u to the denominator, because we have a negative exponent over there. So this is going to be 1 over 3u to the 2/3. I'm going to multiply this u prime times 1, so this is going to be 1 times u prime, but this is simply equal to what u prime is. U prime is 3 minus 10x plus e to the x divided by 3 times, and again you could have left this with fractional exponents. That's perfectly fine, but I'm going to write it as a radical. 3x minus 5x squared plus e to the x. Forgot the square there. And this will be your solution. It does look more complicated than it actually is. Once you get the hang of this type of problems, you will notice that there's always a pattern. These problems are very mechanical. You're always looking for what the inside function is. You're always looking for what the pattern is, and what your substitution will be. Let's do one more just for practice sake. Let's say somebody gives you, find the derivative of sine of e to the 3x squared plus 5 minus ln of x squared. This is going to be definitely much more complicated than anything you'll have on the actual exam. Once again, we have the chain rule. This is going to be u, so u is going to be equal to e to the 3x squared plus 5 minus ln of x squared. Now, the derivative of u prime, is going to be the derivative of this piece plus the derivative of this piece, or minus, doesn't really matter. But notice that both of those pieces will also use a chain rule. So what I'll do is I'll just solve them on the side. So what I like to do is, let's say, call v e to the 3x squared plus 5, and then find v prime, and then let's say you call the other one, let's say h, and that's going to be ln of x squared, and then find h prime. This is a much nicer way of doing the problem because everything is organized. Now the derivative of e to the 3x squared plus 5 is e to the 3x squared plus 5 times the derivative of this piece. Well, the derivative of this piece by the chain rule, so this is yet another chain rule here, is 6x plus 0. Remember, the 5 just goes away because it's a constant. And the derivative of ln of x squared, remember the derivative of ln of x is 1 over u times u prime, meaning it's 1 over x times the derivative of x. So the derivative of this is going to be 1 over x squared times the derivative of x squared, which is 2x. So now we have that v prime is 6x e to the 3x squared plus 5, and h prime is equal to 2x over x squared. And the reason why we did all of that is because that's what's going to give us the value of u prime. So let's put them together now. As we said, u prime is the derivative of e to the 3x squared plus 5, which we just calculated that to be 6x e to the 3x squared plus 5 minus 2x over x squared. And that's u prime. And we now just have to find out what y prime is. Y prime is the derivative of sine evaluated at u. So y prime is going to be, what is the derivative of sine? Well, the derivative of sine is just cosine of x. Well, I'm just going to say cosine of u times u prime. That's the derivative by the chain rule. But now we have found out what u and u prime are. So if you substitute, we have cosine of u. Well, u is just e to the 3x squared plus 5 minus ln of x squared times the derivative of u, which is this whole piece right here, which is 6x 3x squared plus 5 minus 2x divided by x squared. And that will be your solution. Again, this is a much more complicated problem than what you will have for the exam. But this gets the point across, I think, because here we use the chain rule about 3 times. All right, so let's look at another one. All right, so the next problem will be using related rates. So that's problem number 4. So remember that we can use a derivative to find out how two quantities change with respect to one another over time. So let's say we have a circle that has an initial radius of 50 feet. When the radius begins to decrease, at a rate of 4 feet per minute. The question is, what is the rate in the change of the area at the instant that the radius is 12 feet. So again, when we spoke about related rates, I told you that the most difficult part of this problem will be relating the actual variables that you have here. So here we're working with a circle. We are told that it has some radius of 50 feet. We are told that it begins to decrease at some rate. And we are asked to find the rate of change in the area. Okay? Now, what relates in a circle, area and radius? Well, it's the actual area of a circle formula, which is A equals pi r squared. Okay, here we have a clear relationship between the area of the circle and the radius. Now that we have, and by the way, so for the exam, some candidates that you will see, it will be like the equation of a circle, x squared plus y squared equals 1. You may also see the Pythagorean identity, c squared equals a squared plus b squared. You may see the area of a circle, like I just did now, the circumference of a circle, and so on. 2 pi r for circumference, So you definitely, and among others. So you definitely need to know, or at least remember these, to be able to relate the problems. Now, what am I looking for? I am looking for the rate in the change of the area. So what I'm looking for is dA dt. That will be what I'm looking for. This is the rate of the area as it changes with respect to time. What do I have? I have the radius when it's 50. Okay, that's the initial radius, 50 feet. And then I'm looking for when the radius is 12 feet. So I'm looking for when the radius, let me call this R2, is 12 feet. This is going to be R1. And what else do I have? I have the rate of change of the radius, dr dt. The rate of change of the radius is -4 feet per minute. Why -4? Because we are told that it is decreasing, not increasing. So that's going to be -4 feet a minute. Okay. Now, what is missing here from this formula? Well, I have radius. I have actually two values for the radius. Pi is a number, so I don't have to worry about it. But area, I was not given any information with regards to the area. So I would like to know what the area is for the time that I'm looking for. In fact, I actually want to know the initial area, and I also want to know the area at when the radius is 12 feet. So to do that, so let me call this A1 for the initial area and A2 for the area of 12 feet. To do this, we simply plug in the radius into the area formula. So we have a formula. So if you do area equals pi, and I'm going to do R1 first, so that's 50 squared, then what is the area? Well, 50 times 50 is going to be equal to 2500. So we have that the area when R is 50 is 2500 pi. And now if you look for the area when the radius is 12, we have 144 pi. Now, and let me call this A1 and A2. Now I'm ready to go because I have all of the possible information that I might need. I always try to get as much information as possible when doing a problem like this. Now I'm looking for the rate of change of the area when the radius is 12 feet, which means that I'm working on this R2, and when the radius is 12 feet, we know that the area of the circle is 144 pi. And we know that the rate of change of the radius is -4 feet per minute. So this is going to be the most important. These are going to be the most important aspects of what I'm looking for. It's redundant. I have it over there. All right. So what should I do now? Well, remember that the rate of change, we get that by taking the derivative of the equation that we have. So if we take the derivative of this equation with respect to time, t, then what do we have? We have that dA dt, which is what we're looking for, remember that's what we're looking for, is equal to pi times the derivative of r squared. Well, the derivative of r squared is 2r dr dt times pi. This is by the chain rule. Okay, by the chain rule we get this dr dt here. Well, notice that now I have a value for r, a value for dr dt, and I have a value for pi. In fact, we didn't even need this, but I always try to get as much information as possible because sometimes you will get that variable to pop up. Like, for example, I may have had an A. Had this problem been different, much more difficult than this. In any case, here this problem is actually much simpler. So we have dA dt is equal to 2 times r. Well, remember we're working with r2, so that's 12 feet. So it's 2 times 12 feet times dr dt, which is negative 4 feet per minute, times pi. So what is the change in the, what is the rate of change of the area? Well, if we multiply through here, we have 2 times 12, which is 24, and times 4, that will be, well, yeah, can't even think to that. Times 4, that will be 96. Let's see, 2 times 12 is 24, times 4, yeah, 96. So it'll be 48 plus 48. All right, so we have negative 96. You multiply the feet, that's feet squared per minute. Remember the pi is there, so times pi. So it's negative 96 pi feet squared per minute. So this means that the area of the circle is changing, or is decreasing, by 96 pi feet squared per minute. And that makes sense. That makes a lot of sense. You may ask, well, why do you say that makes sense? Well, look how much the area, the actual area, decreased. It went from having an initial area of 2,500 pi to only 144 pi. And it happened very quickly. You could actually figure out how quickly that happened as well. All right, so you will have a problem much like this one on the exam. You will be asked to find the rate of change of a particular object. Let me see there. Another one that's very popular. Let me actually write it. You know, the area of a rectangle. It's another popular one that you may see. The perimeter as well. You know, 2 times L plus 2 times W. So these are all very popular and common equations that you definitely should know, should remember from previous math courses that you've taken sometime in your life. This is problem number 4, I think. Yeah. So moving on to problem number 5, we're going to be talking now about implicit differentiation. We spoke about this for some time, and we spoke about what taking a derivative implicitly allowed us to do. Now, when we take a derivative implicitly, we're taking the derivative with respect to both variables. We're taking the derivative of both variables, x and y. However, when we saw a y, we always wrote dy dx or y prime, depending on what notation you prefer to use. Now, if somebody asked you on the train to find, if somebody comes up to you and tells you find dy dx for, and I'm going to keep this one very simple, for x squared plus y squared equals 25, right? This is just a circle with radius 5. Right? If somebody came to you and asked you that, what you had to do was take the derivative of both sides of this equation with respect to y. So let's see, with respect to x, not y, to x. So let's take the derivative. So we have the derivative of x squared is 2x plus the derivative of y squared is 2y, but because we took the derivative of y, we're going to write dy dx, or y prime. And that's equal to 0 because the derivative of a constant is 0. But notice that now we have introduced dy dx into our problem. So now we simply have to solve for dy dx. The calculus ended at this step when we took the derivative. Once we take the derivative, the calculus step ends. Now what's left to do is simply some basic algebra. You know, move the 2x to the right side, so we're left with 2y dy dx equals negative 2x, and then divide both sides by 2y, and you get dy dx is equal to negative 2x over 2y which if you cancel out the 2's, we get the dy dx is simply equal to negative x over y. And again, this is a very simple problem. The problem that I give you may be much more complicated than this. In fact, it's not going to be that much complicated because you are time on this exam, so I cannot just give you something that you cannot solve in the span of the time that you're given. Like for example, what if I give you something like this, like 3x plus 5x squared y minus, and this may not even have a solution because I'm just making it up, but let's assume that this is what I gave you. You know, something like this. This already has a lot of things going on, but we're gonna, try to solve it as much as we can. Again, our goal here is to find dy dx. And remember that when we take the derivative, the derivative gives us the slope of the graph at of the tangent at a particular point. So let's say we want to find the slope at the point 1, 0. Okay, let's assume that we can actually do this. Hopefully this point works. So let's see what we have here. So let's take the derivative of this implicitly. So the derivative of 3x is simply 3. The derivative of 5x squared times y, we have to be careful here because this is a product, so we have to use the product rule. Remember the product rule? The product rule said that if you do f times g, then that is the same thing as first times the derivative of the second plus the second times the derivative of the first. So we have f times g prime. So let's say f is 5x squared. So that's going to be 5x squared. The derivative of y is 1, but because we took the derivative of y, it's going to be dy dx. In fact, let me do it slower so you can see. So there's no question about what's going on here. Let's say f is equal to 5x squared. Let's say g is equal to y. Then f prime is equal to 10x. And then g prime is equal to 1 dy dx. Because the derivative of y is just 1, but because we're taking the derivative with respect to x, we're going to write dy dx. Alright, so here there's no confusion. So f times g prime is 5x squared times dy dx. So we have 5x squared dy dx. Plus, from the formula, that's where I get that plus from, g times f prime, so that's y times 10x. So I'm simply going to write 10yx, and I'm going to change it up a little bit later. And then minus, again, going back to the formula up here, the derivative of 6y cubed, 3 times 6 is 18, so we have negative 18y dy dx is equal to 0. Let me just write this. Alright, so now that we have done all of this, what we have to do is to move everything that doesn't have a dy dx goes to the right side, and everything that has a dy dx comes to the left side. So if there were values on this side, then you'll move them to the left side. Okay, so what happens here? So the 3 doesn't have a dy dx, and the 10xy doesn't have a dy dx. So I'm going to move those to the right side. So I'm going to be left with, on the left side, 5x squared dy dx minus 18y dy dx equal to negative 3, because I moved the 3 to the right side, minus 10xy, because I also moved this plus 10xy to the right side. Once you have done this, you factor the dy dx on the left side, because it's going to be on every term. So you're going to have dy dx times 5x squared minus 18y, and that's going to be equal to negative 3 minus 10xy. Now, when we divide both sides by 5x squared minus 18y, we're going to get dy dx is equal to negative 3 minus 10xy divided by 5x squared minus 18y. Okay, so this is the derivative. This is the derivative. So what did we do? Let's just recap. First, we took the derivative with respect to x. Wherever we took a derivative of y, we added a times dy dx by the chain rule. We noticed that in the middle term here, we had the multiplication of two different variables. Whenever you have something like that, you will use the product rule, because these are two different functions. Even if they have the same variable like x squared times cosine of x, you will still use the product rule because you're multiplying two different functions. Don't forget the quotient rule as well, because the quotient rule also may pop up from time to time when doing these problems. And finally, minus 6y cubed, we took the derivative as we normally would if there was an x, but then we multiply by dy dx. On the second step here, we move all the terms that didn't have a dy dx to the right side, and every term that has a dy dx, we take it to the left side. On this step, we factor dy dx from all of the terms on the left side, and on the last step, we divide it by whatever was multiplied to dy dx on both sides, so we have dy dx by itself. So we just simply solve for dy dx here. Now I ask for the slope at the point 1, 0. So when the point is 1, 0, what is the slope? So what's going to happen here is you're going to plug in 1 wherever you see an x and 0 wherever you see a y on this equation. So the slope is going to be equal to negative 3 minus 10. Did I put 10 twice? I did. Minus 10 times 1 times 0. And let me fix that order so that you can see it better. Divided by 5 times 1 squared minus 18 times 0. This is going to actually work out very nicely because negative 10 times 0 is 0. 18 times 0 is 0. So you're just going to be left with negative 3 divided by 5. So that's a slope. At the point 1, 0, you have a slope that is negative. So that means that, and there's something we're not going to get into now, that the tangent line, that the function is decreasing at that particular point, because the tangent line is going down. The derivative is negative. That's something that we covered last week. In fact, the next problem that we will do will be exactly on that. So you will have, for sure, a problem on implicit differentiation. So make sure that you go over those. They're not too terrible. Again, most of this problem will involve you taking a derivative and then applying some of the techniques that we have used before. So that's the tricky part. You are liable for remembering all the other rules that were texted on exam 1, meaning you need to know how to take a derivative, you need to know the general power rule, the chain rule, product rule, quotient rule. You still need to know how to take limits, because they may pop up from time to time. You still need to know how to find slope of tangent lines, yada yada yada. All right, let's do another one. Let's find the intervals on which the function f is increasing and decreasing. Okay, if you remember from last time, we had a couple of tests that we spoke about, but the main one that I need you to really know is the first derivative test. As the name suggests, we will use the first derivative to actually find out when a function is increasing or decreasing. So let's say f of x is equal to, let's say, negative 3x cubed minus 30x. Okay, we haven't drawn this function. I'm not going to draw it. We're going to find this analytically. Well, to find whether or not where this derivative is increasing or decreasing, we have to do a couple of things. Number one, we have to find critical values. Okay. Number two, we have to find test points. Number three, we have to, determine where the function is increasing or decreasing, which interval. So how do we find critical values? Well, remember that a critical value happens when the derivative of the function, meaning when f prime of x is equal to 0, or f prime of x does not exist. So if we find a particular point for which the derivative does not exist, like an asymptote, or if we find a point where the derivative is equal to 0, then we have our critical value. This is a polynomial function, so it's going to be continuous at all points in its domain, so we don't have to worry about points not existing. Let's find the derivative of x. What is f prime of x? The derivative of x is going to be equal to, by the general power rule, negative 3 times 3, which is 9, x to the 3 minus 2, which is 3 minus 1, which is 2. And then the derivative of 30x is simply negative 30. The derivative of negative 30x is negative 30. Okay, so we found what the derivative is. Now to find the critical values, we have to solve for when f prime of x is equal to 0. When is that the case? Well, we could substitute back and solve for this. Negative 9x squared minus 30 equal to 0. Now, there are a couple of ways that you could do this. You could move, let's actually solve this way. If we move the 30 to the other side, then I'll have negative 9x squared equal to 30. Then I could add on both sides 9, so I have x squared is equal to 39. And then we could take the plus or minus square root, so we have plus or minus square root of 39. Now, there is no need in us to actually try to simplify this. Actually, we leave 39. Is 39 a prime number? No, 39 is not a prime number. So you could simplify this a little bit more, because you could find two numbers that multiply to 39. But if they're not perfect squares, then there's no point. Like you could list all of the factors of 39, and then write it. So the factors of 39 will be what? 1 obviously, 3 definitely goes in there because 3 plus 9 is 12, and that's divisible by 3. In fact, 3 times 13 gives us 39. So 3 is a prime number, 13 is a prime number. So rewriting this as radical 3 times radical 13 is not going to do us any good. So we could leave x equals plus or minus radical 39 as is. Now, we have to be a little bit smart about this now, because we have a radical number here, 2 of them. So remember, the plus or minus means that we have an x equals to plus radical 39, another x being equal to negative radical 39. And we have to find test points. Okay, remember, you could do it more than one way. You could make a table, or you could do it the way that I was doing it last time, where I made a real number line. So let's say I have 0 here. Somewhere here I will have radical 39, and somewhere here I'm going to have negative radical 39. That I know for a fact, because this is a positive number, this is a negative number. One of them is going to be to the right of 0, the other one is going to be to the left of 0. That I know. The question is, what are the test points? What number is actually less than 39? What number is actually bigger than negative 39? And bigger than plus radical 39. So one way of thinking about this is the following. We know what 1 square is. That's 1. We know what 2 square is. That's 4. We know what 3 square is. That's 9. 4 square is 16. I'm doing it this way so that you could see what I'm getting at. 5 square is 25. 6 square is 36. 7 square is 49. Notice that we have a radical 39. If you take the square root of these numbers on the right side, you will notice that the square roots of these numbers correspond to the 6, 7, 5, 4, 3, 2, 1. Now, radical 39 is between radical 36 and radical 49, which means that radical 39 is definitely less than 7, but bigger than 6. Similarly, on the other side, negative radical 39 is bigger than negative 6, but less than negative 7. So now I can clearly see some test points. So what will be my test points? I am going to test for -7 because that's to the left of -39. So you always pick a number to the left of the critical value and a number to the right of the critical value, always. Now what number is to the right of -39? Well, I'm going to pick one simple number, which is 0. Why? Because 0 is between both of these numbers. There's no other critical value between them. So I could just pick 0 for both of them. And then I'll pick 7 again on the other side. This will make my life much easier because I only care now about which sign the derivative is. Because remember that if f prime of x is positive, then we know that the derivative is increasing on that interval, that the function is increasing on that interval because of the derivative. And if the derivative is negative, then we know that the function is decreasing on that interval. Okay? So we know that for a fact. I gave you guys a theorem about this. So all we have to do is plug these values into the derivative. Well, what is the derivative? We had the derivative up here to be -9x squared minus 30. So let's say f prime of x, and let's see what we get. Let me erase this. Okay, so negative prime f, it's gonna be 9x squared minus 30. So we have here -9 times -7 squared minus 30. Now, here's something that we have to keep in mind. -7 squared is going to be a positive number. You're going to multiply by a negative number. So that means that what you get here is going to be negative. And when you add a negative number to a negative number, you get a negative number. So on the left side of -39, meaning from the interval, this interval from, let me write on this side. The interval that I'm talking about is minus infinity minus radical 39. We have a negative value. This is going to be a negative. So that means that the function is decreasing on this interval. Now, for 0, what do we have? Well, -9 times 0 squared minus 30. We have simply -30, so that's minus. So that means that on the interval negative radical 39 to radical 39, we're also decreasing. So on this interval, we're also decreasing. And finally, on the right side of radical 39, we have -9 times 7 squared minus 30. Again, 7 squared is a positive number, that's 49, times a negative number, that's just a negative number. And when you add a negative number to a negative number, you get a negative number, so this is also going to be a negative number. So from the interval radical 39 to infinity, we are also decreasing. And if we're decreasing on all of these three intervals, then that means that the function is increasing at all of these values from left to right. So that means that it's a function that, may look like this. And it may look like this. It's always decreasing. And how do I know it's going to look like this? Well, this is a negative cubic. So it's going to go down from left to right, and it's going to look kind of like the cubic function. So definitely it's going to be decreasing on the entire real number line. And the question was, find the intervals on which f is increasing or decreasing. Well, the function is never increasing, so it is decreasing on the interval negative infinity to infinity. And that is the solution for this problem. The function is always decreasing. This problem actually covered most of the problems that you'll see regarding extrema. Um, the only thing that it doesn't cover is actually locating the um, absolute min, absolute max, etc. So let's do a problem that actually covers something like this, like the relative extrema. This was number 6. So let's say problem number 7. Find relative maximum or minimum for the function f on the interval -3 to 3. And let's say somebody gives us f to be -5 x cubed plus 3x minus 2. If you're finding relative max and min on an interval, then remember we simply need to find 3 things. We need to find the critical point. We need to use the derivative to find the local max or mins. And we have to find the value of the function at the endpoints. So again, first thing I like to do is to find the critical values. Now, finding the critical values, notice that I'm not using the word points, means the following. When I find out what happens, what values of the derivative on this interval will make the derivative equal to 0. If there are any critical values on this interval, then this is definitely going to give it to me. Well, what is the derivative of the function? The derivative of the function is going to be the derivative of f of x, which is -15x squared plus 3. Now I just simply have to find out when is this equal to 0. So when is that equal to 0? So when is -15x squared plus 3 equal to 0? If we move 3 on both sides, if we subtract 3 on both sides, we get -15x squared equals to -3. Then we could divide both sides by -15, so we get x squared is equal to 1 over 5, because 3 goes into both of them. And then we take the square root of x, so we get x is equal plus or minus radical 1/5. Okay, so now we have a value for which to solve for the critical to find the critical points. This is what we call the critical values. Now, how do we get the critical points? Remember, a point is of the form x and y. To find the critical points, we have to plug in into the original function, which is this one. Now, before we begin plugging in, make sure that your critical values that you're going to be plugging in are on the interval, so that you don't do extra work. Both of these are on that interval because both of these are definitely smaller than 1. Because we have values here that are less than 1. So both of them are going to be on the interval. Had I had a number like, square root of 25, which would have been 5, then I don't have to worry about it because that's bigger than 3, and my interval is only from -3 to 3. But both of these are actually on the interval, so I have to look for both of them. I have to solve for both of them. So what was f? Let me just rewrite f. F of x was given to me to be the following. F of x is equal to -5x cubed plus 3x minus 2. So now I have to solve for 3 things. I have to find out what is the value of f at the square root of 1/5. What is the value of f of the square root of negative 1/5? Radical negative 1/5. F of 3 and f of negative 3. Believe it or not, most problems are nicer than this. The problems that you'll have on the exam are definitely going to be nicer than this because you're not going to have a radical with a fraction. This actually is going to be annoying to solve. Let's just plug in. So it's going to be negative 5. So negative 5. And now it's better if you rewrite this as a decimal. So if you rewrite this as a decimal, it's going to be one. What I mean by that is with decimal exponents, you're going to have 1/5 to the 3/2 plus 3 times radical 1/5 minus 2. And then f of 3 is going to be negative 5 times 3 cubed plus 3 times 3 minus 2. So this is going to be minus 5 times 27. Yeah, minus 5 times 27, which should be negative 135 plus 9 minus 2. So this is simply negative 135 minus 7. So that's going to be negative 128. And then for f of minus 3, we're going to have negative 5. It's minus 3 to the 3 plus 3 times minus 3 minus 2. So this time is everything is going to be negative. So I have, again, negative 135. This time it's a minus 9 minus 2. So now we add everything up very nicely, and this is going to be negative 146. And this ugly thing on this side is going to be negative 5 times negative 1/5 to the 3/2, not plus, minus 3 square root of 1/5 minus 2. Now here's the kicker for your exam. I'm not there with you in your homes. You are allowed a simple scientific calculator. So for a problem like this, which you do not have on the exam, then you could use one. So if you put on the calculator what this is, it's going to be negative 5 times 1/5 to the power 3/2 plus 3 times square root of 1/5 and minus 2 is going to be the top one. So f of radical 1/5 is going to be equal to negative 2.1537 roughly. And then the next one, f of negative 1/5, radical 1/5 is going to be equal to, let's see, so we have a negative sign up front. Minus I see what I did. So it's going to be equal to negative 1.85 roughly. So now remember that we're looking for the absolute maximum and absolute minimum. So when you find the absolute maximum and absolute minimum on an interval, you look for the lowest value for the absolute minimum, and you look for the highest value for the absolute max. So absolute max and absolute minimum. Okay, so what is the lowest value here? Well, negative 146 is definitely the lowest value. So the absolute minimum is negative 146, and it happens at f x equals negative 3. So the absolute minimum happens at the point, let's write it as a coordinate, happens at negative 3 comma negative 146. So this is the point that where the absolute minimum happens, and the absolute maximum happens at the highest number. Well, the highest number is actually negative 1.85 because it's closer to 0. So that's going to be negative radical 1 over 5 comma, and this is again approximately negative 1.85. So that's where the absolute maximum happens. Again, the problem that you have on the exam is not going to include a radical like this one. I didn't even write it. Oh yeah, I did write it. Product of fraction. It's not going to include a radical like this one at all. So that should make your life much easier. It definitely should make your life much easier. Okay. All right. So let's do one more. I believe this actually will be the last problem, or rather the last topic that you will definitely need to know for the exam. Let's see. Yeah. What problem was this one? 7. So 8. So here we simply have to use the first derivative test to find the absolute max and the absolute minimum. Okay. Not the absolute, the local, the relative max and the relative min. My apologies. So let's say f of x is equal to 2x to the 5th minus 5x to the 4 minus 10x cubed plus 4. Okay. So let's say you're given a function like this. If you're looking for the max and mins of this particular function, then the first thing I suggest you do is to take the derivative. You take the derivative of this, you get 10x to the 4 minus 20x cubed minus 30x squared. Now, next thing you should do is solve for when this is equal to 0. Notice that you could factor from each of them 10x squared. You could actually factor from each of them at 10x squared. So you'll be left with x squared minus 2x minus 3 is equal to 0. This makes our life much easier. On the inside, you could actually factor that a little bit more, because negative 3 times 1 is equal to negative 3, but they add up to negative 2, so we could factor it a little bit more. So you have x minus 3 times x plus 1. So now, by the principle of zero products, we have that when x equals 0, x equals 3, and x equals 1, this is true. So these are our critical values. Okay, so we have 0 as a critical value, 1 as a critical value, and 3 as a critical value. So now all we need is test points, and then we can use the first derivative test to find out what the absolute max and minimum are. So I'm gonna write the test values in red, because that will help me differentiate between the actual critical values. So the first test point I'm gonna pick is -1. The second test point I'm gonna pick is 1/2, and the third test point that I'm gonna pick is 2. and the fourth one, because I need one to the right of 3, is going to be 4. Again, you always want test points between any critical, to the left and right of any critical value. So 0, I have 1 to the left and 1 to the right. 1, I have 1 to the left and 1 to the right. 3, I have 1 to the left and 1 to the right. It's okay if critical values share a test point. Like, for example, 1 and 3 are sharing 2. That's perfectly fine. If we do this as a table, so let's do this as a table, test point f prime of x, and then the sign. Actually, instead of sign, you could also write behavior, if you want it. You could say it's increasing or decreasing. So we have -1, 1/2, 2, and 4. And f prime of x, let's remember what that was. That is 10x squared. Always use the factor version. It makes your life easier. If you already went all the way to, if you already factor all the way, might as well use it. So it's 10x squared times x minus 3 times x plus 1. So if I plug in -1 here, I have 10 times -1 squared, -1 minus 3, and -1 plus 1. Well, what do we have here? We're gonna have a 0 here because, wait, did I write something wrong? Oh yeah, I did something wrong. This is -1, so this is actually not supposed to be there. -1 is actually a critical value, so I'm gonna pick -2 instead. Yeah, and -1 is actually a critical value, so let's pick -2 here. So instead of having -1s here, I'll have -2s. -2, -2 -2 minus 3, and -2 plus 1. There we go. So this is going to be a positive number because -2 squared is plus, and 10 times a positive number is a positive number. There's going to be a negative number here because -2 minus 3 is -5. And there's going to be a negative number because -2 plus 1 is -1. So plus times minus is actually plus, because minus times minus is plus, and plus times plus is plus. And by the first derivative test, if the derivative is positive, we know it's increasing. So when we are to the left of -1, the derivative is going up. Okay? What about when we are, and instead of 1/2, actually, now that I know that 1 is not a test point, I could just simply pick 1 as my test point on this side instead of 1/2. And I can remove this 2 from here. All right, so let's see what happens here. So we have 10 times 1 squared, 1 minus 3, and 1 plus 1. So plus times plus is plus. There's going to be a negative number because there's going to be a -2. This is going to be a plus. Plus minus plus is actually minus, because plus times minus is minus, minus times plus is minus, this is minus, so that means that we are decreasing. So on the interval between 0 and 3, we are decreasing. Finally, to the right of 3, at 4, we have 10 times 4 squared, 4 minus 3, and 4 plus 1. Everything here is positive. Notice that the only thing that we have to worry about is this, but this is just a 1, so it's a plus, this is plus, and this is plus. So to the right of 3, we are increasing, so this is all positive. So we go back up. Now, let me make this line in black. What happens if you did it the way that I did it with this graph? Then when you make your graph like this, you can see that here you're going to have a maximum, and then here you're going to have a minimum. Again, if you have increasing then decreasing, that's a max from left to right, and if you have decreasing then increasing, that's a min. So now we know that the local max occurs at the critical value, which was whoa, hold on. I said -1. I'm missing a number here. Missing a number here. -1/2. Not so fast. I mean, it is gonna be. I'm missing a -1/2 here, and the reason why I'm missing a -1/2 here is because my value is -1 and 0 instead of the 1 here. So I have to find out what's happening here. So not so fast. You can always catch your mistakes by doing that. So we just have to calculate one more. I have a hunch that it's gonna be going down as well. Well, let's see. So for -1/2, let me erase all of this. -1/2, we have 10 times -1/2 squared -1/2 -3. Maybe not, maybe I'm wrong. And -1/2 plus 1. So again, this is going to be positive, this is going to be negative, this is going to be positive. Oh, I was right. So it's going to be going down. So it didn't change anything, thankfully. So it's going down, this is going up. I will explain what happened at this critical value here at 0 in the next lecture. All right, so we can now say that the local max occurs at -1 so at x equals -1, and the local minimum occurs at x equals 3. And again, it cannot be 0 because at 0 we don't have neither a max nor a min. So if I put the line again, this actually goes down and then down again. So remember, when it goes down and down, let me erase this one so you can see it better. When you go down and then down again, there's neither a max nor a min. You just keep on going down. It's just decreasing. And this is as far as the difficulty will be on the exam. I think this is probably going to be the most difficult problem using the first derivative test. And again, the first derivative test mainly, the biggest idea is finding the critical values and then finding the test points. Good luck to all of you on the exam. That will be all for the review. I will be hosting office hours at the time posted on Blackboard. So if you wish to join for office hours, you're definitely welcome. Thank you for your time.